Welcome to aminacademy.com. In physics, let us discuss about sound. What is sound wave? A sound wave is the pattern of disturbance caused by the movement of energy traveling through the medium such as air, water or any other liquid or solid matter as it propagates away from the source of the sound. Sound waves are created by object vibration and produce pressure waves. For example, a ringing telephone, the pressure wave disturbs the particle in the surrounding medium, and those particles disturb others next to them, and so on. The pattern of the disturbance creates outward movement in a wave pattern like sea water in the ocean. The wave carries a sound energy through the medium, usually in all directions and less intensely as it moves farther from the source. The idea of sound moves in waves goes back to at least the 1st century BC, the Roman architect and engineer. The origin of the modern study of sound is attributed Galileo Galilei. Sound waves are longitudinal waves. Now, let us discuss about equation for sound speed. Here, the speed v equal square root of gamma RT over m for ideal gas. Now, here R is the gas constant. R is a gas constant. M is molecular mass. Molecular mass of the medium, molecular mass. And T absolute temperature. And V is speed. And gamma is ratio of specific heats. That means specific heat at constant pressure and constant volume. Next, further V equal, then further V we can express as a square root of modulus over density. Here it changes at bulk modulus over density. It changes material medium to medium. Next, speed of sound in air. Here, speed of sound in air at 0 degrees Celsius is 331 meter per second in air. Suppose the comparison V1, V2 is the square root of T1 minus T2 temperature ratios. Next, the intensity of any wave. What is an intensity? Intensity of any wave is the energy per unit area per unit time. In practice, it is the average power carried by the wave through a unit area erected perpendicular to the direction of propagation of the wave. Suppose delta T, an amount of energy is delta E. Delta T is change in time is carried through an area of delta A that is perpendicular to the propagation direction of the waves, then we can say intensity is equal delta E, change in energy, over delta A into delta T. Delta T, change in time, which is further equal power average over delta A, because delta E by delta T is the power average. Now, which is further expressed as 2 pi square f square rho v is 0 square. Here f is the frequency hertz, rho is the density, v is in meter per second velocity, a0 is the maximum displacement of atoms or molecules of the medium in meter. Therefore, I is, the unit of I is in watts per meter square. Next one, loudness. Loudness is a human perception of how intense a sound is, that is, it's measured on a logarithmic scale. It is a measure of your human perception of sound, although a sound wave of high intensity is perceived as louder than a wave of lower intensity. The relation is far from linear. The sensation of sound is roughly proportional to the logarithmic of the sound intensity, but the exact relation between loudness and intensity is complicated and not the same for all individuals. Definition: loudness is the way we perceive the pressure of sound, and it is used to differentiate between sounds that are loud or faint. Measurement: loudness is measured in decibels, dB, which is based on the human threshold of the hearing. For example, a sound that is 20 dB is 100 times more intense than a sound that is 0 dB, and it sounds 4 times as loud. Scale: the dB decibel scale mimics the human range of hearing by filtering out high and low frequencies that people can't hear as well. Next one, amplitude. The amplitude of a sound wave is directly proportional to its loudness. So, if the amplitude of a sound wave doubles, the loudness quadruples. Noise. Sound wave of about 80 dB are considered noise to the human ear. That is, intensity or loudness level is beta equal 10 log intensity by intensity I0. Next, intensity of loudness level. What is intensity of loudness level? Sound intensity and loudness are related, but they are different concepts. What is intensity? The amount of sound energy that passes through a unit area in a second. It's measured in watts per square meter. Loudness: how loud a sound seems to a listener based on the ear's response to the sound. It's measured in decibels. The intensity of a sound wave determines its loudness, which is how the ear perceives the intensity. For every 10 decibel increases in intensity, the sound's loudness increases by factor of 10. The average least perceptible sound is at 0 decibels, while sounds near 100 decibels are often considered uncomfortably loud. Health organizations recommended that people avoid exposure to sound above 85 decibels for more than 8 hours per day without hearing protection. What is beats? The alteration of a maximum and minimum intensity produced by the superposition of two waves of slightly different frequencies are called beats. The number of beats per sound is equal to the difference between the frequencies of the two waves that are combined. Next one, Doppler effect. This interesting one. A Doppler effect, also called Doppler shift, is the change in the frequency of wave in relation to an observer who is moving relative to the source of the wave. Look at here. Here, while siren sound is produced by a vehicle here that going towards the hearer here. So he hear high frequency sound. But at the same time, this person, this vehicle go away from his position. So the frequency is reduced. Frequency of sound is reduced. Actually, Doppler effect or Doppler shift is the change in the frequency of wave is in relation to the observer who is moving relative to the source of the wave. The Doppler effect is named after the physicist Christian Doppler, who described the phenomenon in 1842. A common example of Doppler shift is the change of pitch heard when a vehicle sounding a horn approaches and recedes from the observer. Compared to the emitted frequencies, the received frequency is higher during approach, identical at the instant of passing by, and lower during the recession, go away. When the source of sound wave is moving towards the observer, each successive cycle of the wave is emitted from a position closer to the observer than the previous cycle. Hence, from the observer perspective, the time between cycles is reduced, meaning that frequency is increased. Conversely, in the source of the sound waves is moving away from the observer, each cycle of the wave is emitted from the position farther from the observer than the previous cycles. So, the arrival time between successive cycles is increased, thus reducing the frequency. For waves that propagate in a medium such as sound waves, the velocity of the observer and of the source are relative to the medium in which the waves are transmitted. The total Doppler effect is such a case may therefore result from the motion of the source, motion of the observer, motion of the medium, or any combination thereof. Therefore, the frequency f0 equal fs into v plus v0 over v minus vs, where here sound free that suppose a moving sound source emits source frequency. This fs is source frequency. Fs is source frequency and f0 is what? F0, the observer sound frequency. Frequency observer, and v is speed of observer is vs, speed of observer, and v is speed of vehicle. V is the speed of sound, speed of then This is the relation. Next one, wave interference. What is wave interference? When two or more waves interact, they can interfere with each other in different ways. For example, when two waves are in phase, they combine to create a wave with a larger amplitude. It is in phase, it creates a larger wave. For example, when two waves are in phase, they combine to create a wave with a larger amplitude, which is called constructive interference. When two waves are out of phase, they combine to create a wave with zero amplitude, which is called destructive interference. This is destructive interference, this is constructive interference. So far, we discussed about something about sound and its effect, various effects we have done. Please subscribe our YouTube channel.